Section 10.2, Rational Exponents. In Section 10.1, we worked with integer exponents. In this section, we work with exponents that are rational numbers. For the counting number n, where n doesn't equal 0, if n is odd, then b raised to the 1 over n is the number whose nth root is b, and we call b to the 1 over n the nth root of b. If n is even and b is greater than or equal to 0, then b to the 1 over n is the non-negative number whose nth power is b. We call b to the 1 over n the principal root of b. If n is even and b is less than 0, then b raised to the 1 over n is not a real number. B to the 1 over n may be represented by the nth root of b. So for example, I want to simplify 25 to the 1/2. So what 25 to the 1/2 means is that I'm taking the square root of 25, or the second root of 25, though we often don't write the 2. So the square root of 25 is equal to 5. So 25 to the 1/2 is the same as 5. Then I want to simplify 64 to the 1/3. So 64 to the 1/3 is the cube root of 64. So the cube root of 64 is equal to 4, since 4 raised to 3 is equal to 64. Next I want to have negative 64 raised to the 1/3. So I want to take the cube root of negative 64. So I can take the cube root of odd number, or I could take the cube root of negative numbers. So this would equal negative 4. Since negative 4 times negative 4 times negative 4 equals negative 64. I want to simplify 16 to the 1/4. So 16 to the 1/4 is the fourth root of 16. So the fourth root of 16 is 2. Since 2 times 2 times 2 times 2 is equal to 16. I want to take negative 16 to the 1/4. So keep in mind that in this case, this is equivalent to negative 16 to the 1/4, where 16 to the 1/4 is in parentheses. So this would equal to negative the fourth root of 16, which would be negative 2, since the fourth root of 16 is 2. However, if I put the 16 in parentheses, then I would be looking for the fourth root of negative 16, and I can't take the fourth root of a negative number, so this is not a real number. So there is no solution to this, or no real solution to this. For the counting numbers m and n, where n doesn't equal 0 and b is any real number for which b to the 1 over n is a real number, then I have these two conditions. So, if I want to simplify 25 to the 3 over 2, this is equivalent to me taking the second root of 25 and raising it to the 3. Or it's the same as me taking the square root of 25 and raising it to the third power. So this 2 acts as the root, the 3 acts as the power I'm raising it to. So the square root of 25 is 5. I'll be raising that to the 3, which gives me 125. Now I want to simplify negative 27 raised to the 2 over 3. So what this is the same as is me taking the cube root of negative 27 and then squaring it. The cube root of negative 27 is negative 3. If I square that, it gives me a positive 9. I want to take 32 and raise it to the negative 2 over 5. So I would be taking the fifth root of 32 and then raising it to the negative 2. So that's me taking 2 to the negative 2, which is 1 over 2 squared, which is equal to 1 over 4. And then if I have negative 8, I would be taking the cube root of negative 8, raising it to the negative 5. So this would be negative 2 raised to the negative 5. So this would be 1 over negative 2 raised to the 5, which is 1 over negative 32.